Hi, welcome to another teaching video of Jiggy Math. This is Miss Darlene. Please join me and learn how to express division as fractions. First, let's use this scenario. Suppose we want to share 2 chocolate bars equally among 3 children. What fraction of a bar will each child get? This problem can be solved by using diagrams. First, let's draw 2 holes representing the 2 chocolate bars. And each hole is divided into 3 parts for the 3 children. Now let's start distributing 1 part for every child. Another part goes to the second child. Third piece goes to the third child. Let's do the same thing for the second bar of chocolate. 1 part goes to the first child, the second one, and the last piece goes to the third child. By looking at this diagram, we can see clearly that given 2 chocolate bars, each child would get 2/3 of a bar. Now, this problem can also be solved without using diagrams. 2 holes divided equally into 3 parts can be expressed as 2 divided by 3. And as a fraction, it can be written as 2 over 3 or simply 2/3. Take note that when we divide a smaller number by a bigger number, we end up getting a proper fraction, which means that the numerator is smaller than the denominator. Now let's practice some more how to write division expression and the corresponding fractions. If we have 7 divided by 8, in fraction form it is written as 7/8 or 7 over 8. If we have 5 divided by 9, in fraction it is written as 5/9 or 5 over 9. Take note that we have proper fractions here, meaning the divisor or the denominator is always greater than the dividend or the numerator. This time we are ready to learn how to express division as mixed numbers. Let's use this scenario. Suppose we want to share 5 cakes equally among 4 children. How much cake would each child get? Here in this problem, we can use diagrams to solve this. First, let's draw 5 holes to represent 5 cakes. And then, we can distribute 1 hole for every child first. 1 hole goes to this child, another one for this, for the third child, and for the fourth child. Now we are left with 1 whole. Let's divide this into 4 equal parts so that each child will get a small part. So 1 part or a quarter goes to the first child, another quarter goes to the second child, another piece for the third child, and the last quarter goes to the fourth child. Now in this diagram, we can see clearly that given 5 cakes, it can be shared equally among 4 children and each child will get 1 whole and a quarter or 1 and 1/4. Now, this problem can also be solved without using diagrams. 5 to be shared equally among 4 children is the same as 5 divided by 4. And in fraction form, it is equal to 5/4. In the last video, we learned that an improper fraction can be expressed or can be converted into a mixed number by using the long division process. So if we are going to divide 5 divided by 4, how many 4s are there in 5? We have 1 whole. 1 times 4 is 4. And then if we subtract the 2, we will have a leftover of 1. So 5/4 is the same as 1 whole with a remainder of 1/4. And this is our answer. Isn't it the same as the ones that we have here using a diagram? Now let's practice some more. Let's express each division expression as a fraction. Then, let's rewrite the fraction as a mixed number. So if we have 16 divided by 5, in fraction form, it's the same as 16 over 5. Now let's use a long division process to convert this into mixed number. How many 5s are there in 16? We have 3. 3 times 5 is 15. Subtracting the 2, we have a remainder 1. So 16 over 5 is the same as 3 wholes and 1 over 5, or simply 3 and 1/5. Now let's go to the second example. 18 divided by 7. It's the same as 18 over 7. Since we have an improper fraction here, let's convert this into a mixed number. So 18 divided by 7 will give us 2. 2 times 7 is 14, and we'll have a remainder 4. So 18 over 7 is the same as 2 and 4 over 7. How do we know that our answer is correct? Now let's take a look at this answer. 2 wholes with a remainder of 4 over 7. In the last video, we've learned that we can change mixed number to improper fractions by doing these steps. First, let's multiply the denominator by the whole number. So 7 times 2 is 14, and then the answer will be added to the numerator. 14 plus 4 is equal to 18 over 7. Now our answer here is the same as this one. Let's have another example. 23 divided by 7. Let's express this division expression as a fraction. So this is written as 23 over 7. Now this time, let's rewrite this fraction as a mixed number. How do we do that? Let's use the long division process. How many 7s are there in 23? We got 3. 3 times 7 is 21. 3 minus 1 is 2. So we got 3 wholes, a leftover of 2 over 7. Now 14 divided by 3 is the same as 14 thirds. Let's use the long division process to convert our improper fraction into mixed number. How many 3's are there in 14? We got 4. 4 times 3 is 12. Subtracting the 2, we have a remainder of 2. So 14 thirds is the same as 4 and 2 thirds. For our last set of exercise, let's try answering more challenging questions. Express each division expression as a fraction in its simplest form, and then rewrite the fraction as a mixed number. So if we have 24 divided by 9, let's write this in fraction form. We got 24 over 9. Let's simplify this. Since 24 and 9 have a common factor of 3, let's divide the numerator and the denominator by this number. So 24 divided by 3 is equal to 8. 9 divided by 3 is 3. So 24 divided by 9 is the same as 8 thirds. Now, since our answer is still in improper fraction, we can still convert this into a mixed number using the long division process. So 8 divided by 3 will give us 2 wholes. 2 times 3 is 6. 8 minus 6 is 2. And we have a remainder 2. So 8 thirds is the same as 2 with a remainder of 2/3, or simply 2 and 2/3. Now let's go to the last example. 33 divided by 12 in fraction form is 33 over 12. The numerator and the denominator still have a common factor, which is 3. So let's divide each by 3. So dividing them, we'll get 11 over 4. Now let's express this in mixed number using the long division process. 11 over 4 will give us 2 times 4 is 8 and a remainder of 3. So 2 wholes and 3 over 4. So this is our final answer. For more exercises, you may refer to My Pulsar Here Mathematics 5A or Math Buddies 5 by Marshall Cavendish Publishing. Thank you for joining me.